Hi, welcome back again. I hope you're beginning to enjoy your maths and seeing light to many things, especially curve sketching. Now, with what you know about curves, about linear graphs, and what we have done on quadratics, the knowledge that you know, we're now going to apply into curve sketching. Now, let's look at a linear graph. You remember the equation of a linear graph? Y is equal to mx plus c. Right, m stands for the gradient and c stands for the intercept. If we ask you a question like this, how would you sketch a graph where m is less than 0 and c is less than 0? How do you interpret m as less than 0? Well, m is less than 0 on a number line. It means smaller than 0, which is example -1, -2. Any line on a number line, this is 0. Going this way, m is greater than 0, and going the other way, your m is less than 0. So this shows that there is a negative gradient. And on top of that, look at your c. Your c is less than 0. And less than 0, it means that y, if you look at this, mx plus c, and if c is less than 0, and if your x is 0, look at it. It is going to be cutting at the y-axis, where x is 0, another name. So in the first case, in the graph of A, where m is less than 0, c is less than 0, your graph can look like anything like this, where the gradient is negative. Got it? Negative gradient. The c is below the y-axis. So this is a situation of a straight line, A. In the case of B, when the m is a 0, the gradient is a 0. It means there is no slope, and the c is less than 0. How does the graph look? Well, the c is less than 0 if this y-axis, x-axis, and the c is less than 0, no slope, right? It can be anywhere as long as it is below this point of origin 0, 0. So in this case, the m is equal to 0, your c is less than 0. Any line parallel to this, as long as it is below this point. I would reiterate again, as for the earlier graph, here, m less than 0, c less than 0. It can be any one of these graphs. Or it can even go like this. Or it can be a graph like that. All of these graphs show that a gradient is negative. It's a downward slope, and the c is below the line. Now what happens if we have m greater than 0 and c equal to 0? Can you make a guess? Right, you got it, I'm sure. With all that practice that we have been doing earlier on. This is the x, this is the y, and m is greater than 0, c is equal to 0. It means that when x is 0, your y is a c, and your y will be a 0 too. So this is when c is 0, right? Your graph is y, right, equals to mx. And the c here is none other than 0. That is in the condition where c is equal to 0. Got it? It's a positive gradient. And here, I would say the graph here, the gradient here, m is greater than 0. C equal to 0. Now what happens if you have m greater than 0, c less than 0? Well, it means like that. M is a positive gradient, but C is less than 0. So this is M greater than 0, C less than 0. Let's do another one. M greater than, let's do another one like this. Like for example, if I want to draw a steep graph. What is this? It is a positive gradient, increasing very steeply. But your C is here. It is less than 0. It's below the origin, 0, 0. All these are positive gradient. What happens if I said, hey, I want M to be greater than 0 and C to be above 0? Well, I'm sure you know by now what the graph looks like. Can you make a guess? Yes, it is a positive gradient with a C positive cutting above the x-axis. Unlike here, where C is less than 0, is below the x-axis. Or if I have another graph like this, if you look at the difference between these two graphs, the slope here is less gradual, whereas the slope of this blue line is steeper. The rise is faster, alright? But they all meet at the same point here in this case. Or I can have a graph like this. The C is greater than 0 and the M is greater than 0. Have you got this picture of linear graphs? Alright, this is curve sketching and it gives you a very good picture of what linear graphs are all about. When they have the same gradient, remember, they are all parallel. Now let's look at a sketch of this graph. This is, do you remember? Yes, it's a quadratic equation. Is it a smile or is it a frown? It is a 1 here, a silent. So it is a smile. The shape of the graph will be like this. When x is 0, y is 0. Y-axis, x-axis, this is y is equal to x squared. If you look at the next one, you have an x squared plus 1. How does the graph look like then? It's the same shape of the graph, but it's pushed up 1 step plus 1. Alright? So if I were to draw the graph, look at it. B, if this is y and this is x, is pushed up 1 step. So this is 0, 1. If x is 0, y is 1. And the name of the graph y equal to x squared plus 1. Got it? It's the same graph, but it's just moved up 1 step. If it's plus 2, you just move it up 2 steps. Now, if you look at this one, it is y is equal to x squared minus 1. So how does that graph look like? Minus 1, the graph is pushed down. And this is a point when x is 0, y is minus 1. X is 0, y is minus 1. Y-axis, x-axis, your y is equal to x squared minus 1. Look at this graph carefully. Does it have roots? Yes. How do you know if it has roots? A graph that cuts the axis, the x-axis, the 2 points here are called roots. There are 2 roots in this graph. Unlike here, there is 1 root. In this case, there is no roots because it does not cut the axis. Please do remember, no roots. Here, one root. Alright, you have one root. And where's the root? Here. Alright, and in this case, there are two roots. The roots are here. Two roots. What are the two roots then for this? We can factorize this graph, alright? What, x squared minus 1, you get x plus 1, x minus 1. So the roots are, if you make it equal to 0, x is minus 1 and 0, which is this point. And here you get 1 and 0, the other root, and 1 and 0. Have you got the picture right? Good. Now, we are going to look at more of curve sketching. What happens if we give you a graph like this? If I said, alright, x squared minus 3x. Are you able to sketch the graph? Right? You said, alright, we can get it as, this is question 3, x minus 3. Right? Remember it. And the roots are going to be, when y is 0, one root is 0, the other root is 3. 0, 0, 0, x is 3, and y is a 0. The graph goes this way. In any root, we have to find, like when you draw a graph, when you have two roots, the midpoint, that will be the turning point. The last lesson, the previous lesson, we learned about the turning point. Do you remember it? Ah, you got the trick. It is the midpoint of the x. You add the 2x, 0 plus 3, and you divide it by 2. So the x, the turning point, will be, for x, it will be equal to 0 plus 3 divided by 2. That's 1.5, right? So when x is 1.5, that is the line of symmetry. And how about the y? You take that and you put it in. You got it. So what will the y be? Well, it is x is 1.5 squared minus 3 times 1.5. So this will give us, you remember 15 times 15? 225. So in this case, as a one decimal place, 1.5 times 1.5 is 2.25 minus 3 times 1.5 is 4.5. Now if you take away, you get a minus 2.25. So that's going to be the minimum point for y. Alright? So when x is this, your y is minus 2.25. So this is the minimum point. And whenever you draw any graph, as I said, key pointers must be mentioned. Your x here is 1.5, your y here is a minus 2.25. And the name of the graph is y is equal to x squared minus 3x. Of course, please label the axis. Alright? So this is just the first preliminary sketch on curve sketching. As we go on, we're going to find out more.